Okay, so now we can do a little bit of problem solving with vectors. So let's say we have a sailboat here, and someone was trying to get from here to here. This is the way it's set up. So she's trying to start out here, and she's trying to end up over there. She first travels along 2 kilometers, kind of in a due east direction. Then the wind blows her this way. She goes 3.5 kilometers here at an angle of 45 degrees, kind of south of east. So south of east, like if I was on east and I go south of that, that would be my angle, right? So that's the way I would say that. And then we want to find out, she's like, I have to get back to here. I need to end up over here. So how do I need to chart my course now that the winds have died down, or at least not blowing her out of the way? How do I chart my course to get back over here? So we really need to find out kind of this last vector to get us to where we want to go, right? We're gonna have this this displacement that we want, and we kind of have some of the displacement we've already had, and now we need to just find out what is the last piece, right? So first thing we can do is start labeling all our vectors, so we can kind of start adding them together and getting some resultants and whatnot, and then we want to break it down into kind of like an algebraic problem, right? So first, I'd like to just label some of these vectors, right? So we have, clearly I can't, I mean, I guess I could, label that as like one vector, but that doesn't make a whole lot of sense. I might as well just label what's given to me here, make life easier. And so I'll call this vector A, and I'll call this vector B, and then I can call this vector C over here, whatever that is. And the three of these should add together to give me vector R, which maybe I'll do over here. Okay, so this is my resultant vector. And this resultant needs to be the sum of vector A plus vector B plus vector C, right? This is what we need to do. Now we know something about some of these vectors. I know that I'm given here a direction and a magnitude for vector A. So I know a lot about vector A, and I'm given a magnitude and direction about vector B as well, so I know a lot about that one. I know nothing about C, but I do know something about R, right? We do know that it should start out here and end over here. So and we know the distance is 5.8 kilometers. If I assign a coordinate system to to this north, south, east, west, then I can just apply. Maybe I'll call my positive x is in the east direction and my positive y is in the north direction, right? So we can kind of talk about this in terms of our familiar Cartesian coordinate system here. In which case, I can say that the resultant should only go in the x direction. It should just go due east, which would just only have an x component. So this resultant vector should actually add up to 5.8 kilometers in the x direction and nothing in the y direction, right? So this would be my resultant. Okay. So I can have here the idea is, let me just kind of write all this out here. I can write out A in vector format with some AX, AY. I can write out B in some vector format, BX, BY. I can write C out in a vector format, CX, CY. These are all in kilometers. And it all needs to add up to vector R, which should be, what did I say that was? 5.8. 5.8 in the x direction, and 0 in the y direction, kilometers, right? So you can see from this that we must have AX plus BX plus CX equals 5.8, right? So we have AX plus BX plus CX is equal to 5.8. And we must also have AY plus BY plus CY equals 0, right? So AY plus BY plus CY is equal to 0. And that gives us two equations and two unknowns, right? Because we can find AX, AY, BX, BY. The only things we don't know are CX and CY. The only unknowns we don't have, or only unknowns we have. And so we can then solve this system equation to find CX and CY. Once we have CX and CY, well, then we have, C is in this form here, and we can find the magnitude and direction just from Pythagorean theorem and trigonometry, right? So this is our strategy that we can use here. First, kind of lay it all out, and then write out the equations that we must have, the kind of the vector equations that must be true, and we can solve from there. So the next thing to do is we have to find these components, right? Because we weren't given, A and B in component forms, we're given magnitudes and directions. Of course, vector A is at, well, let me actually write these out. Vector A, maybe I'll write them just beneath here. We could say vector A is 2 kilometers at 0 degrees, and vector B is 3.5 kilometers at either negative 45 degrees or 315 degrees, either way. Okay, so then we can find our components there. Let me just write these out down here. So AX, this is going to be 2 cosine 0, which is just 2 kilometers. AY is going to be 2 sine 0, which is 0 kilometers, right? And then we have BX is going to be 3.5 cosine of, I can use reference angles 45, or I can say this is 3.5 cosine of 315. Either way you do it, we will end up here with 2.47 kilometers. And BY will be, if I use reference angles, negative 3.5 sine 45. Or I can say this is 3.5 sine of 315. And this is, and just looking at it, we should end up here with the negative, right? And this is, and actually the fact that it's 45, you probably remember from trig classes, it's going to end up being the same, kind of magnitude there anyway. So we end up here with a negative 2.47 kilometers. So there's AX and AY, BX and BY. Just rearranging this stuff, we see, CX is going to be 5.8 minus AX minus BX, and CY is going to be equal to 0 minus AY minus BY. Just a little algebra there. And so from this, you can do this arithmetic, I think, on your own. So we get CX is equal to 1.33 kilometers, and CY is equal to 2.47 kilometers. Or writing it out in vector notation, vector C is 1.33, 2.47 kilometers. Let me just pause for a second and think, okay, that's going to be going into the first quadrant, right? And important thing here, it's not where the vector is. Remember, where vectors are is the vector doesn't matter where it is in space, it's only how it travels, right? So this should be going up and to the right, which if I look back at what we have here, the third leg, if I'm down here and I need to get here, I need to go up and to the right. So kind of fits the general direction, and it looks to me, if this is drawn to scale, then it needs to go up more than over, which is kind of what we get here as well. So we have the magnitude of vector c, just from Pythagorean theorem. This comes out to 2.81 kilometers. And then the angle that she'll need to travel will be the arctan of this 2.47 over 1.33, and that comes out to 61.7 degrees. In standard position, right? I guess I could call it north of east, right? If you have measured, let me write out the whole thing. So vector c would be 2.81 kilometers at 61.7 degrees, which is perfectly fine. You can leave it at that, or you can say north of east for anybody that might be a sailor. Then you'd kind of head, this is your bearing, right? So north of east, I had my east, and I go north of that, so that's the standard position, angle there. But yeah, so this is her heading to get back to the finish line.